Okay. Mic check on. Alright, today we're going to look at the cubic. Now, I just want to stress the next 2 weeks are just going to be about looking at different types of graphs. And I know so far we've only seen two. So we've seen the straight line, which is y equals mx plus c, and the parabola, which is y equals ax squared plus c. I just want to stress that everything we're doing in this topic is kind of the same thing, just over and over again, but with a different graph. So if you feel like you're struggling with this, it's not actually any different to any of the other lessons. And that's going to be the kind of the theme for the next 2 weeks. It's only going to be the point that the graphs are going to change, the way that we transform them. So when I say transform, I mean like Krish again, really? Hi. The way that we transform them may change. So let me just, in other words, have a look at this m. What does that do? That changes the gradient or the steepness. Same thing with this a, it changed the gradient or the steepness. This c on the end, all that did was change how high or how low it is. It's no different, and depending on what the graph looks like, it's actually exactly the same. So today we're going to look at a cubic, which you can see it in the top left of your screen. It's actually y equals ax cubed plus c. And again, the numbers do the exact same thing. This is just going to change how steep it is. If that's a minus, it's just going to be upside down, just like these ones. This one made it upside down like that. This one made it go this way. So this a here is going to do the exact same thing. And this plus c is literally just going to raise it up and down, just like before. So it's exactly the same. We're doing the same thing, it's just the graph is going to change. So yeah, I guess that's all I have to say. So the graph. What graph are we actually looking at today? Well, today we're looking at y equals ax cubed plus c. Now I'm going to try and introduce new words every lesson, and these words can actually be transferred to any graph. So when I guess annotate each of the numbers here, I don't want you to think of it in terms of just a cubic, like you know how I was calling y equals mx plus c, you know how I was calling that the gradient? Well, that's the gradient for every graph. Like this is still the gradient. Just because I call this the gradient in the straight line doesn't mean this isn't a gradient. So I'm going to start introducing words each lesson, and they can be transferable. So you can talk about any graph using these words. Oh, that's not right. Okay, so this one here, this a, yeah, that's the gradient. But a number that is multiplied by your x cubed, or like any variable. So the number that's multiplied by a variable, that's called a scalar. So scalar just means like I'm extending it. So let's suppose I've got the number 2. If I wanted to scale that or make it bigger, I'd multiply it by something. If that something's bigger, it's going to scale it longer. If it's smaller, it's going to scale it smaller. So that's just a scalar. The number on the end, so if you're adding a number on the end or something like that, that's called a constant. So I'm just going to introduce a couple new words, but it's essentially the exact same thing. When you've got y equals mx plus b, m is a scalar, and the c or the b on the end is also a constant. Okay, I've taught nothing for the last 3 minutes about cubics, so let's go on with that. All right, I just want to, so I guess what you can see in the top corner of your screen, that's kind of what it looks like. So remember, your straight line looks like this, your parabola looks like this, and your cubic kind of looks like a parabola, except this part of it kind of is upside down. That's, I guess, the way you need to look at it. There's a reason for that, which I'm hoping people will get in a sec, but your graph kind of looks like this. Let's go like this, y, x. So it's like a parabola this way, and then this way is like an upside down parabola. Okay, so that's y equals x cubed. And it's important to recognize what the original graphs look like, and which is why I try and put it in the top corner of the screen each time. Because when you go to transform them, and transform means when I start adding numbers here and here, then it's a good idea to have like a reference point. Like what did it look like before I started adding numbers to it? So there's a couple of things I want to just write about in terms of what a cubic actually is. Let me draw some dot points. The first thing is that it has no symmetry. Whoops, I know I wrote an A there. Has no symmetry. So remember with the parabola where you were asked to find the axis of symmetry? Well, obviously this doesn't have any symmetry. It has nothing, like I can't draw a line across it. It does actually have one form of symmetry, and it's called rotational. So it has rotational symmetry. So rotational symmetry means I can get this graph and physically twist it. If I twisted it around this way, I'd end up kind of on the same spot. I can't really visualize that. Actually, yes, I can. No, I can't. Let's grab this. So if I like rotate it, see how I've done a half rotation, it looks exactly like it did before. That's called rotational symmetry. Now, another thing, if A is bigger than 0, so this A here, if it's a positive number, it's going to look like this. And what I mean by that is, I guess, another way of describing what it looks like in this shape is if you read a graph left to right, which is how you should read all graphs, just start here. What's actually happening to each of these points is that it's increasing. So it's an increasing graph, which just means it goes up, essentially. So it's an increasing, we'll just call it increasing. And the opposite can be said for if A is less than 0, then it's decreasing. So if you just look at the top left corner, I'm going to make A less than 0, so I'll make it a negative. See how it just flips it, kind of goes like this way instead. And again, if I make A large number, it gets skinnier. If I make A a smaller number, it gets wider. So exactly the same as before. Hey Krish. Now this C on the end, again, the constant, that's kind of why it's called a C, constant, or K for constant. I don't know. Again, that just moves up or down. So same as every other graph. So really, if you understand that the A and the C, what they do in every graph, then you're not going to have any trouble. It's just, again, what this thing makes it look like. All right, let's actually graph some stuff. Screw the examples. Let's just draw our own, eh? Let's just do 3. Y equals, we'll start with positive. X cubed plus 2. Let's do that. Boom, boom. 1, 2, 3, 4, y, x. Okay, I always just use the original as a reference. The original looks like this. Now it's just going to go up to, which means this point here is up to. So literally same thing, half parabola, half parabola. That point is 0, 2, and that's enough to say that's y equals x cubed plus 2. When you're doing the exercise, can you please label your graphs? Because it's really easy for me to, because some people ask me, do my graphs look okay? And then I kind of have to open the textbook and then cross-reference it kind of thing. But if you just write what it is next to it, then it's heaps easier for me to see. Let's go -1. Actually, I have an interesting question. What if I had this? Oh no, actually, screw it. I don't want to confuse people. Like this. I'm going to do a challenge after this. Whoops. Look, to be honest, we don't go that far in terms of other graphs. Okay, so there's my y-intercept, still the same thing, y-intercept. Now this minus tells me it's upside down, so upside down. And this is like basically the y-intercept, or down 2. Okay, now it's upside down, which means positive parabola, negative parabola. Label it. Oh, label this point 0 minus 1. Y equals negative x cubed minus 1. Look, I don't think I need a third example. That's pretty much as far as we go. I guess one way to summarize what we've done so far. So remember how I wrote here. I'm just going to write it. X squared plus c. I want you to think about the 3 types of graphs we have done so far. Now, really, we can just call that A. I don't know why we call it M. We call it M because with a straight line gradient, or like, I don't know, to be honest. But just have a look at those 3, or this one. Have a look at those 3 graphs. They're all identical. The A's and the C's all do the exact same thing. What I want you to realize is this pattern doesn't stop. So next lesson, what we're going to do is actually keep going, x to the power of n. But there's one thing I do want you to think about, and it's have a look at this one. See how it was this parabola like this. And this one here is a parabola that goes both positive and negative. So think about this, like this is a positive parabola, this part of it's a negative parabola. The reason, I'm going to leave that up to you. If you can tell me the reason why a cubic is able to go positive and negative, and that's called a quadratic is able to go only like this, if you can tell me, then I'll be pretty impressed. but we're going to go over next lesson. I might put a challenge one in here. Oh, this is what I was going to say. That's the point. Remember before how we had y equals like ax squared plus c, and that's kind of as far as we go in every other graph, but we went a little bit further with parabolas and we said, okay, what if we had y equals a, and then I added something in here. I put a h there for lack of better things. Remember I put this in there, and that was one whole lesson. We don't actually do this for any of the other graphs. We only do that for parabolas. We're going to do this for every single type of graph in advance, but for parabolas, this is kind of as far as we go, and every other graph like this as far as we can go. But all we're going to be doing with graphs is scaling them and raising them. This was just a little bit of an extra thing that we got to do with parabolas, but there's no reason why we can't stop with parabolas here. I could give you the example of y equals minus x plus 3 squared minus 2. Theoretically, you should be able to graph that, but it's not in our syllabus. So that's going to leave that to you as a challenge. But it's not in the scope of the course, which means I can't test you on that. So yeah, that's kind of it, I think. Like I said, next lesson we're going to look at y equals x to the n, which just means any power. But I don't want to make this video too long because it's really not that hard and there's not that much to it. But yeah, just get used to the types of graphs. So in this case, a cubic, and making these transformations to them.